All right, welcome back. This video is our second video within lesson 1.2. And this one is going to be talking about sampling. And for our sampling here, we're going to talk about different types of collecting our data. So previous section, we were looking at types of graphs. Now we're going to start getting into how do we generate statistics and what do we do to get that data. And this is a really important section. And we have a homework assignment on this, but then also we have a project on this as well. It's a pretty straightforward one, but you are going to be breaking up data into different groups based on the different samples. So you just really need to make sure you understand this. So if something's unclear, please go back over the slides or check out the textbook. So sampling, gathering our information about our entire population is often too much, costs too much, or impossible. So instead, we're going to sample the population. And there's a bunch of different ways to collect that data. So simple random sampling, or SRS for short, it's a straightforward method for collecting the random samples. So an example of this would be to give each member of the population a number, then use a random number generator to select who you're going to get. And it's just a way to completely randomize it. And that's pretty much what we're going to be doing for almost all of these, but there's going to be a little bit of a twist on it, or more specifics. So for example, say we want to make a 4-person study group from a pre-calculus class, 31 students in the class. What we could do for that is just assign everybody a number, 1 through 31, and then we could pick out 4 of those numbers. You could even go to Google and pick 4 random numbers between 1 and 31. And it should work. Maybe Google apparently doesn't. Usually it should work for you, but here it's just a random the one. So it pulled 4 people for us, and we'd be able to see who that was based on a list. Here's like a sample of the list, and you could use the graphing calculator for that as well. We're going to use more computer applications than graphing calculators. Here's another way to pull people randomly. Here's a bigger data set, so 731 students. And if we want to pick 8 students, they have all of these numbers listed. And what they did was they took this list of random numbers and they broke it up going every 3. And so here they took 71966. They broke that up. They went every 3, 719, put a line. Then they took the next number, 662, line. And then 738 and a line. And so that's a way to break it down to get random students. So student 719, 662, 650, 4, because it's 004, student 53. So it's a way to, another way to make random numbers, but this is way, way more tedious than just a random number generator. Okay, so that's random number generators pulling students or pulling people or data. The next parts are going to be more specific pieces. And this one's a really good one. It's called a stratified sample. To do this, you divide the population into smaller groups called strata, and you take the proportionate number from each stratum, so from each group. So you just break it up into different groups and then pull a few people from each group. So for example, you could break up your college population or your college by department and then choose the proportionate simple random sample. So give everybody a number and then pull people from each of those groups, from each stratum or each department, to get a stratified random sample. So for example, suppose there are 5 departments and you want to choose a sample of 50. What you do is just break that up into each 5 departments, and then you pull 10 from each department using that random number piece. And then you get up here 50 people, and you get each department represented fairly. It's also assuming each department has the same weight. we kind of do this for our electoral college for presidential elections, right? But we give different weights to different states because North Dakota, obviously way smaller population-wise than California. Okay. Next is called a cluster sample. Divides the population into clusters, groups again, and then this one's kind of weird. It randomly selects some of the clusters or one of the clusters, but then all members of that cluster are in the sample. So back to our college example, we have 4 departments in our population. The 4 departments make up the cluster sample. We put everybody into a department. Departments are the clusters, and then we number each department and then choose 4 different numbers using simple random sampling to get, okay, so yeah, here we're randomly sampling just 4 departments. So there's more than 4 departments, maybe like 10 departments or 20 departments. And then we simple random sample 4 of those. But then when we do pull them in, we get all the members from those departments. So this one is a little more tedious in the sense where you're not really in control of the total number of data points you're getting in. In our previous one, we had only 50 data points. This one, we're not really in control of that. So, and you get everybody from that sample. So a little different in that regard. All right, a systematic sample. We randomly select a starting point and take every nth piece of data from a listing of the population. So this one is pretty logical. For example, let's say we're doing a phone survey. We have 20,000 listings, and for a systematic sample, instead of choosing a random number generator, we're creating a system to pull the numbers for us. So for example, they would pick if we want to pick 400 names, if you take 20,000 divided by 400, what do we get there? I think 50. So we'd pick the first person or whatever, wherever we start. Maybe we use a random number generator, maybe like the 23rd person. Then we add 50 to that. So then we'd pick the 73rd person, then add 50 to that. And so take person number 123. So that would give us a cross section of that whole phone book until we get to 400 people. So that's systematic. Pretty similar to simple random sampling, but it's just every increment we pull somebody. Then convenience sampling is actually kind of a pretty good name. Convenience sampling is really convenient. It's taking what's in front of you and sampling them. So it's non-random. So right there, not very good. It involves using results that are readily available. So, for example, a computer software store conducts a marketing survey by interviewing potential customers who happen to be in the store. Browsing through the available software, results of the convenience sampling may be good in some cases and highly biased, favor certain outcomes and others. So, yeah, I mean, I guess this computer software store, they would be sampling people that are interested in computer software because they're in their store. So those people probably are not a fair representation of, people across the world or people across the state or city or whatever they're trying to investigate. An example of convenience sampling would be, maybe I ask students how they feel about online learning, but I only ask the distance learners via email, and I don't ask the hybrid learners. And that wouldn't make much sense because we need to know what everybody thinks about distance learning. So it's what happens when you just ask a certain subset of people. All right, so those are our types of samples. We have quizzes on that, and we also have an activity on that. And I will make another video talking about that activity. All right, bye.